牵挂，你叫我，我叫你，大家心相连。铜章马公鸡海让路，耗子马遗憾浪靠边，白克马争流千帆尽，波涛在后浪在前。
Introduce CMSCAPP Visual Script Controller Platform. Today we try to introduce the whole menu of CMSCAPP to introduce briefly, give the customer a big sketch of the system. In CMSCAPP, we have two menus. One is main, just showing on the screen. The other is in teaching mode. The main and the teach. On the background is the big screen itself, while the program functions are listed surrounding the left, the right, and the button, and the Windows menu on the top. In the main menu, started from the left up, the yellow area for graphic process. In the middle of the screen, a Fanaka 710 robust is used, and with material functions we set a raw material, and we use DSF file input to install a 2D joints on the center of the material. The graphic procedures. The first one, the view pass. As the DSF file input on the top of raw material, then a CAN pass created. You can see the data at the data field. Go back to the main. If we choose to use view pass, as press the left button as the cursor on top of a view pass. The N tool of GM code X, Y, Z, U, V, W, G00 will shown on the left button of the big screen, while the corresponding points will mark here. We can press a Q key of the keyboard to shift to N2, and then the corresponding white start will move one forward. Keep pressing and the cursor will moving one by one, slowly. If we want to see the cutting path faster, then we can together press Control key and the Q key. The N line will showing at the left button, and the corresponding white start will moving faster to show the user how the tool cutting on the real parts. If we want to try to see one line in front, just press the E key, then we'll back one instructions. Keep pressing. The white star will backward slowly. If we want to try to run faster back, just press together the Control key and the E key. This is the function of the view path. If we try to cease the program, just press the trace off. The trace on, the same as view path. Let's choose it, but only the white start. No NC file list at the left button. The same with Q, go one by one. With Control Q, go forward faster. And with E, go back one by one. If we want to fast the speed, just press Control and E together. Trace off. The last one, start lights. The program can be run not from the starting the line number 2. We choose the start light to set the line supports to 100 and press OK. You can see N200 list at the button left position, and the corresponding white start located in here. Okay, this is the functions to show the graphic path of the NC running. The left yellow area is file in and file out. In here we have two NC file in functions. One is DSF input, another is M3 DGM input. The DSF input is FNAC, is AutoCAD DSF file, could be input, and in our system we'll create it combined with the DSF parameters definitions, created the 2D toolpath immediately showing on the screen, simply because this system is a controller. We need a CAN path to drive the system running, working for us. The DSF file in is to create 2D toolpath only. If you want to use 3D paths, then have to use M's for meaning 3D GM input. This function can let us to input millions 3D GM codes file, NC file, into CMSCAPP system. The 3D NC file, including 2.5D NC and 2D NC file as well. The 4D NC file and the 5D NC file are not allowed in this function. In LobaCAN, in Loba system, there is no GM codes G54's definition. If we want to mirror or doing some working at the working area of Loba, in this system, we can allow the user set material size. So you can set the user's material at anywhere around the working area. Then tell the system to input the DSF file to locate the join on the center of the material. Then you can place the raw material anywhere to mirror the parts, just the equivalent to the function of G54. For any toolpath showing on the screen, we can output by using GM output to create a GM output by CMSCAPP system. This is 6-axis GM output, which can be loaded next times by using R6D GM input to load in the system and running next time, running the cutting and the working next time. The rest of 3 function is LobaCAN use. Any toolpath here, we can use LobaCAN's output. The output file can be loaded into individual Loba controller and running, and to control that Loba's working. The PCS output is output the NC file for the format of Denso. JBI output is output the NC file for Loba Yaskawa. LS output is for Fanaka format. Nazi output is for Nazi Loba. So this is speaking about the file in and the file out. At the bottom, the hand area, the handle by manually. Since CMSCAPP is a controller, the basic controller functions supports to find the home position of each axis, to set the jog along any axis, to start the movements and doing 6-axis interpolations, all controlled by this area. There are 3 homes setting. The first one, home. If you press X and press home, the system will finding X homes for you. As the moving touch the home sensor, the system will search home automatically for you. As the home moving, you have to use only stop home functions to stop the moving. This is one way to find home. The second is home plus plus. You can move the system SYZ or SRYRZ to any position on the physical machines, and at one moment, at one XYZ or SRYRZ, that position, you just press home plus plus. The system will recognize that specified points as the home points, and later on to cut or to put your raw materials and cutting your plates. This is arbitrary setting home positions. It's very useful and accepted and welcomed by the customer. Another one is loader. More and more robots use absolutely motor. Absolutely motor, as you stop the machines and reopen the machines next working day, you need to set home. How to do it? As you open the system next day, simply pressing loader, the system will go back to the original situations, just like the one day before, 6 the machines situations. So 3 ways to find homes. Now jog plus, if you press Z and press jog plus, the physical machines will run along Z positive directions, running and running, never stop, until the system touched the Z positive limit. As touch the limits in here, like Z positive, this one will become 1. The system will stop. If you want to go again, you have to use clear to clear the error and put the system back in the safe area. Then you can rerun the machine. As the moving stopped, then you can press the jog malus to drive the system running any directions in the malus direction. As jog plus or jog malus running, you can press the abort to stop the moving immediately, or press stop function to stop the machine deceleration in deceleration. You can move the coordinate to any positions simply by press X and give a value, or Rx and give a degree, 60 degrees. You can choose whatever you want, and press circle starts. The system will move from these positions and to the specified positions. All these functions are manually operated, so we write in the hand areas. This area program and this area, the main menu and the teach menu are all the same. Right now we go to the teach menu. In teach menus, at the left top button is teaching functions. In LOBA, 80% program is by teaching. The engineer handle the teaching pattern to teach the robot to do this, to do that, and log the data and deploy it to work always like this. The teaching data will record at the data area. Suppose we use renew to clean the data and to change the coordinate to join modes. Then we talk about the teaching method. The main teaching is line, polyline, or arc, polyarc. The polyline started with a start points. The next one use line. You can use move to move anywhere and press line to adopt the second, the third, until you don't want to continue. The last one, use end point to end the polyline. The arc, the same, start with start points. The arc need 3 points. The middle points, as you move to the new positions, press arc to input the second points of the arc. If only one arc, then the third point use end points to create an arc for you. If you want to create a poly arc, the first one still press start points and then move to the new positions, press arc, and to new positions and press arc again. The arc 3 points, as you press the end points to make sure the end points will end at the arc number of the arc polygon definition. And we have two spatial geometry. One is single points. You can move to anywhere and press single points. And there's a spatial functions is arc. You can move SYZ J1 to J6 to any position. The position can set as the center of a circle, and then choose the circle functions to draw a radius circle around that center points, and then move to another center positions and set the circle again, etc. And one really useful functions is set arrays, like the examples for welding the iron bed. We simply define one segment of the welding, since the iron bed just like a race. Then with one piece, welding lines created, then use the array functions to set X space or Y space, and with X directions number and the Y direction number, the system will create the rest path for you. If, for example, if the welding for hundreds, then you cannot set each piece one by one. It takes long times. If it is a race, then you just set once. That's it. Very convenient. And the set loop. If the teaching finished, we want to cut the parts for hundreds. We just set loop for hundreds. Then running the program, we are running 100 times for you. And not only teaching for moving, but also teaching for I/O. Suppose we move to somewhere, some positions, and set I/O to set Y output to cross the clipper to hold the parts, and then lift to move to the new place, and set I/O to loose the clipper and to set the parts to dead positions. Then for these operations, we have to clip and loose. We have to use set I/O functions. The set I/O not only set input and output of the PLC, but also the procedures input. The set delays can let us at anywhere to delay for any seconds if you want. You can also edit by yourself one by one by add one function, add one at the last function. Okay, this is teaching. The teaching function is always what we call inverse process. What is the positive process? We have talked already. The DSF in and the GM code in is the positive NC process, while the teaching mode is inverse process. No matter the positive process or the inverse process, NC file is NC file. All the NC file in the data field can be edited by editing functions. At the teaching mode, left hand area, the editing function has plenty of functions. Not only the save CC, load CC, and renew, and insert, and delete And modify, we discuss, we introduce and use these functions a lot. One thing I have to introduce is there are several buttons. Suppose like this one. An invisible line in the center to divide the function into head and the tail. The front is head, the rear is tail. Let's create something on the data area. Suppose like this, we have 6 lights. Right now, is the last line is the button. How can we move to the front? Simply at editing head tails, we just put at the left and press left button, and the data will point to the number 1 instructions. Or better, to reload the data for demonstrations. So renew and change back to the Cartesian coordinate system and change back to the main menu and reload the DSF file and the beauty DSF. The data will create here and join in here. And in edit modes, the data field point to the line number 1 and the corresponding start located at here. We can use edit line number. Suppose 250 line number. Okay, so the data field will point to 250 lines in here and the corresponding mark in here. And we can use modify to modify any values of these lights if you want. If there is a real machines, you can use move tool to let the machines tooltip moving to these points. Okay, we continue, go back to introduce the half and half. The head right now is 250. If we want to go to the head, we have to put the cursor at the left parts of the menu of this item, this button. Then press the left button of the mouse. The system will shift the instruction back to the instruction number 1. As you put the cursor at the right side of the button, then press the left button of the mouse, the system will moving the index to the last line of the data area, and the cursor will showing the last points. Another one is next record, a invisible lines in the center in here. If we right now we are at the rear, we want to go one lines in front, just put the cursor at the left parts of the button and press the left button of the mouse. Then you can see one line up. keep pressing, then you can see the start will go backward one by one. And the same, if you press the right half, then will increasing one instructions and go to the real. Another one, and the last one is next page. If you put the cursor at the left half and press the left button of the mouse, right now indicate to 3071. One page is for 6 lights, so press the left button and shift one page to the line 3065 and keep pressing. The system will move one page and then one page to the front faster than next record. If you want to move back, just shift the cursor to the right and press the left button of the mouse. The system will go to the front faster and faster. Okay, this is the editing briefly introduced. No matter the NC from the front pass or for the inverse pass, provide there is a data can be edited by these functions. The data area can be saved into the disk by save CC. The data area, if you want to see in ASCII code, you can save CSV file and then open the CSV file to see it more clearly, and you can edit by Excel to alter the CSV file. After editing, okay, use load CSV file, reload that file back to the data area. Okay, let's continue to introduce useful functions. Move. The move and the teaching modes left button. We are handling 6-axis machines. In here, suppose in join mode J1 to J6, you can see J1 plus, J2 plus, J3 plus, J4 plus, J5 plus, J6 plus. As you press J1 plus, you can see the J1 become 2, become 10. Another press become 20, 30. If there's a physical machines, the tooltip will locate at J1 at 50 millimeters positions. For any J1 to J6, I can press the positive or minus. You press, this is teaching mode. For the physical machines, you press the J1, the button will change color to the pink, and the physical machines will continue moving until touch the limit, and the minus as well. If you want to stop the moving, you have to press the same button again, and the pink will go back to the white. If you use the 100,000 speeds too fast, Then you can lower the speed to hundreds and press a J3 to let it go slowly, slower. If you fast, slow, the speed can control by yourself. This function is very handy for operating manually. Okay, now go back to introduce the command function, the program. If there is any data in the data field, you can press run. For the simulation modes, you can run simulation in simulation. If the physical machines available, the physical machines will running in real time, just like the simulation. Both machine, virtual machine and the physical machines all run together. If you want to stop the machines, just press stop to stop the running, or press reset to cease the running. Now moving, not only the motion control cars moving, but also controlled by the piston of PLC's output commands. "22" green small button showing the PLC input, and the 32 yellow buttons showing the situation of PLC output. And the input area can show the procedures input number as well. While in the command left right button area, in here shows station number 1. You press and then shows station number 2, station number 3. If there's no machines, just showing mechanical modes. If you go back to the station 1, it is a robot. Use scene input to load on the screen. So the first station is a robot, is controlling a robot. In robot, we have join modes. In join mode, you can see the encoder report J1 to J6 encoders values. While you press the left button of the mouse as the cursor locates at these positions, the system will change to Cartesian coordinate system. The tip locations XYZ, RX, RY, RZ. Some system set ABC, XYZ, ABC will show the tip positions for you. So the Cartesian coordinate and the join position can be changed as you press to choose the CCS or join system. And here will change, and data area will change automatically for you. This is to report the current positions according to the physical machine's encoder. If the system touch the positive limit switch, then this line will become 1. the physical machine will stop. If the system moving touch the negative limitation, these positions will become 1 to tell the user the minus limit for the specified axis is touched. That's the reason why the machine no moving. You have to handle it before using the system working. Okay, before we introduce the menu, we introduce the menu 3, the I/O table. This is I/O. Put the cursor at anywhere in this area and press the left button of the mouse, or put a cursor at L positions. Press the left button of the mouse. The system will go into the menu 3, showing the I/O table. Right now, showing the Modbus TCP IP purity 1, and showing the I/O table, the input and the output data. The input and output data can be edited by the user. Simply putting the cursor at here and press the right button and change editing the input data for the specification of the I/O table, and output the same. Press the right button and editing the output data. The input and output data can be Chinese and English. And after editing, you can save the I/O, which can be reloaded later on by load I/O. For any system, any definitions, all can be saved and can be reloaded. Not only the CC file can be saved and load, and save CSV file and reload CSV file. The delete after and reload it back. Okay, let's go back to see the last introduce. The top list on the top, the menu. The menu is defined by the Windows system. So into the function is very fast, while the rest surrounding is defined by CMSCAPP. The system has to recognize the position of the cursor as you press the button, and to tell which button you are pressed, and running that function for the user. The first one of the menu is the file. In file, you can see a save and load job file, and save and load back the view of the camera, and save surface direction and load surface direction as you use IGS file, IGS-A and IGS-B finished definition, the geometry model on the screen. You can save as a surface direction file, and which can be loaded back by using load surface direction. As you load surface direction back, you can set the color for the geometry model and load back. The system will show the color models for you. The second main and the teach we talked already. The parameter, we have several parameters. The first one supports break length. The default is 0.55 millimeters. Just like the DSF is a NURBS curve, we have to separate the NURBS curve into a polygon. How many distance for one light? The distance setting by black length. Right now is 0.55. So for this one is 0.55 individual points. If you running think it's too slow, you can enlarge this value and to run the robot cutting this joint faster. It is very important. Sometimes the users always keep 0.55 to run, suppose like this, to do milling. Use the robot 5-axis swaying robot to run the cutting. It seems very slow, the speed, because this one too short, too accurate. You have to enlarge, suppose, to 2 millimeters. Then the speed is 4 times faster than this value. And we can set the G00 speeds in millimeter per second per minute, and you can set the feed speed and we introduce a radius. Right now the screens turn mask to full screens to show the full screen, because in here screen we used one adjust screen. For these screens, the aspect ratio is 16:9. For the standard of our system is 4:3. The resolution is 1024 multiply 768 dot pixel. In this case, the showing the screen only to this size. How can the system to show in full screen? Because we used adjust. The system will fetch the screen's resolutions and enlarge the screen to the full screen for you automatically. If we define the physical machine's 6-axis positive and negative limitations too short, and we insist to run the physical machines to an area, then we can use one open the limitation. Then the system will running and running until it touch the hardware limitation sensor and then stop. It won't be stopped by CMSCAPP program. That means by the scene we have limitations setting. In the CSV files, limitations won't limit the software limits is cancelled, and you can let the system running in off light simply by change of lights. 0 become 1, break. The virtual machines on the screen will break the connections with the physical machine. whatever you can, if you can try and use and learn to use to change the value and to see what will happens and to understand the usage of CMSCAPP. The input script we talk already. For the automations procedures, we have to set the CC file in the input script action specifications. We can save the script file after editing and then reload the script file later. For the PLC automation modes, we have 9 stations running, and we can control 9 PLC machines. For 9 stations running together, we have to install the machines. We have to prepare for each stations in input script P1, P2 until P9. And for the automation control, we have to press the PLC modes. And right now is PLC number 1 we are showing on here. And to press the input button of the procedures to actuate the corresponding CC file. The new button will clean the data, the drawing on the main screen, just like the first time into the CMSCAPP system, and then can use the sync input from station 1 until station 9. As station 1 to station 9 settle down, or view set to the right positions, then you can use sync output to create a single big file for you. Anytime if the system is running or not running or located at arbitrary positions, you can use reset to let everything go back. Use reset to stop the running. And the motion car is to control the data of the motion control cars parameter. This parameter is copied from motion test. The motion control car in this instance is all we using ITRI's motion control car. The motion control car has several basic functions like home, jog, cycle start, abort, stop. These kind of parameters we have to adjust or to suppose home to have to test by motion test of ITRI. The motion test you can download from the website of ITRI. As the running, the testing, the jog, the home, the limit, everything, suppose the position, the speed, something like the gain, the P gain, the settle times, whatever. You just log the data from the motion test and feeding the field of this area. That's it. There is an SOP for motion control car. Before using CMSCAPP, running our APP program, we have to make sure the motion control, the model, the wire connections, the system controllable. You have to be make sure by motion test. This is the responsibility of ITRI. We have to make sure everything okay by motion test, and then copy the parameter into our system by means of the motion control car's function. Another SOP is the PLC. The motion is not only the motion control car. The output of the PLC can push the relays and open the switch to open the facilities moving by piston. For us, the motion control axis moving can be replaced by using the PLC output driven by the piston, while the piston moving can be replaced by motion control car. Depends on how much you want to spend, how accuracy you want to drive the system. So there is another SOP is before the WinPro Reader, which is downloaded from the FATEC website. You have to make sure the input and the output, the wire, the connection, the PLC, everything is in good conditions before running our program CMSCAPP. These two motions has to handle first, because the PLC wire connections and driven by wire output all belong to PLC's functions. You have to make sure by WinPro Reader, not by our system. If the motion test and WinPro Reader's job finished, then running CMSCAPP, the APP functions surrounding the cutting, whatever's, the teaching, the fire in, the handle, whatever, all is our responsibilities. The Modbus is two specifications for FATEC PLC Modbus, and the Modbus setting is the TCP setting, the tool settings, the tool geometry change by Modbus setting function. The IGS file, there are plenty of IGS file translate from variety CAD system. Some CAD system is good to pass a standard IGS output, while some is no good. In our system, it's better use Panasonic CAD output. While for CADIA, the IGS file translate into our system supports like Euclid. IGS file is no good, especially Euclid. This IGS file always have a gap between surface. That's the reason why the Euclid public their source on websites give a name as OpenCascade. Anyone can download OpenCascade and use to write their own KCAN system. And this S model can allow the system to open a S file. The S file can be translated by Polytrans, SandyMax, Music, whatever. The S file can be loaded into 3D acceleration card. So we use these functions to see the transformations. The S file is alright or not. If you can open the S file by using these functions on this system, then this S file can be feeding the scene CSV table can be used in this system. The canvas, if there is a IGS 3D geometry model on the surface, you can run in 3D surface along boundary. Suppose for water jet cutting a hole on a surface, or you can use 3D surface along face. Suppose grinding or polish a propeller, zigzag or whatever. And for this is light. You can use robot light guide path to lead the robot running along this line. The line could be DSF or create by GMNC file, or can use robot light guide path functions to create the inside to a leading path. For something like welding or water jet, we have to along the lights, but with an inclined angle. Then you can define to the inclined angle path for your cutting. The remote control is available. Suppose we have a machine, 3 axis, 2 stations water cleaning machines delivered to Thailand. If the system gets trouble, ask help from here, Taipei. Then the screen, on the screen, that the machines, the screen just like you have seen. Then you have to open the same scene file. And in Taipei, we have to open server. The system will create an IP for you, and you pass the IP to the engineer in Thailand beside the machine, and the engineer use open client and use the passed IP to connect with the server in Taipei, and then in Taipei, we can control the Thailand's machines, the moving the encoder of the 6-axis, or if multi-machines, or can return to Taipei and showing on the screen, on the server, and I/O situations and whole running situations can be seen in Taipei, and we know what happens if the system stop in somewhere. Then we can tell what's wrong in the machines and finding the solutions to tell the engineer beside the machines to fix the machines. In this way, it's faster for the maintenance and provide better service for the customer by the remote control function. The webcam is for the robot to seeing the scene. Yesterday, I visited the exhibitions in Langang. I show Mitsubishi demonstrate AR. It's just like this, showing the big screens, while our ARs, we locate the functions at the top and the bottom, just surrounding it, leave the big area to show the real scene. While the Mitsubishis put the instructions at the top and the center of the scene, hide the scenery, and one thing, hide the scenery, the menu put it in the center is okay. I don't have any complaint, but I don't like they use VR's helmet, a helmet with a glass. The engineer, operating engineer says the screen will project on the in front glass, so the operator can see the scenery on the helmet, and trace his hands with 2 fingers to clip the manual. Suppose stop the robot running or open the robot to run, etc. function, just like the way we put our manual's surroundings. The sailor doing the demonstrations try to open to clip one button. He clip once, twice, 3rd times, and then opened. Always to clear something and then redo it. And he open, let the visitors training. The visitor putting the helmet on head, try to learn how to operate. I never see anyone, any visitor can open any functions. No one can open. The training very awkward. 1 times, 2 times, very not that easy to learn. In here, you just use the mouse, or by using the teaching pattern, or even by controlled by handphone. It's all handy, better than the hermit, better than clip by hand. The finger is too big. You cannot control accurately. The mouse, the point of the cursor, is very accurate to pick any functions in anywhere. To set, suppose to pick X, it's too small. For the finger, your finger is bigger than X and Y and Z. So it's really easy to mix up X and Y. Okay, this is what I said, my own opinions about the hermit, about to use VR's facilities to control the ARs or CPS controlling. The error code, if the system running, some error happens, you can press the error code. The error code will respond the error message. Then the user can check the notebook to find out, oh, it's the some models get troubles, and what the troubles, the notebook will tell you in detail. And according to the engineer's experience, can remove the error immediately and keep running the machines to work in efficiency. Then ending.
轻轻对着断，是爽快自由。